This question is asking us to find the locus of a point that is equidistant from 1, 3 and 3, 5. So let's get our points 1, 3 and 3, 5. Say this is point Q. We have 1, 3. Good. And this is point Q. Oh, sorry, there should be a Q here. Okay. So this point Q, which is 3, 5. So this is point P. The first we must do here is that we must notice that when we asked for the locus of point equidistance from 2 points, it's simply the perpendicular bisector. So that means the line we're looking for is the perpendicular bisector of this line. And what it does is it's perpendicular to it. That means it's at 90 degrees to it. That's 1. 2, it divides this line into 2 equal parts. So if this is M, let's call this point M. That means MQ is the same thing as PM. They are the same. The first we must do here is to get the gradient of the required line. The required line is, let's say, line AB. Okay, so the required line is line AB. We want to find the equation of line AB, but line AB passes through M. So the first we must do here is to get the gradient of line PQ. That will help us to get the gradient of line AB. So let's find the gradient of line PQ. Gradient of PQ equals, as usual, y2 minus y1 over x2 minus x1. And for gradient or line PQ, if this is y2, sorry, that should be y2, that should be x2. X2, this is y2, then this will be x1, y1. Fine. So if that is the case, our y2 here equals 5 minus y1 is 3 divided by x2 is 3 minus x1, and x1 is 1. So 5 minus 3 equals 2, and 2 divided by 3 minus 1 is also 2. That equals 1. So the gradient of line PQ is 1. And do not forget, line PQ is perpendicular to line AB. When two lines are perpendicular, note this, when two lines are perpendicular, the product of their gradient M1 M2 equals minus 1. So if gradient PQ is termed M1, we want to find gradient M2, which is for the line AB. Let's do that now. M1 is 1, M2, that's what we're looking for, equals minus 1. 1 times M2 is M2. That means gradient M2 equals minus 1. In other words, gradient of line AB is minus 1. So let's write that. Gradient of AB equals minus 1. So we've been able to find the gradient of line AB. The next now is to determine these coordinates of M, that is the midpoint of line PQ. And to get midpoint of line PQ, since it's a perpendicular bisector, look at that. So coordinates of M equals x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. Do not forget, for M2 we're considering, sorry, for M we're considering points P and Q, because it's the one dividing points P and Q into 2 equal parts. So y2 plus y1 divided by 2, x2 plus x1 divided by 2. So let's solve that so that we just move straight. And that eventually becomes x2 from the question is 3. So we have 3 plus 1 divided by 2. And y2 from the question is also 5. So we have 5 plus 3 divided by 2. 3 plus 1, that is 4. 4 divided by 2. 4 divided by 2 equals 2. And 5 plus 3, 8 divided by 2, that is 4. So point M is 2, 4. We're almost done with our question. This simply means that line AB has a gradient of minus 1, and it passes through point M, which we have just got to be 2, 4. Okay, now let us solve. Finally, we use gradient 1 point form. Gradient 1 point form using gradient 1 point form, because now we know the gradient of the line AB and we know the point it passes through. So gradient 1 point form. Gradient 1 point form tells me that y2 minus y1, or better still, we have it as y minus y1 over x minus x1 equals m. Okay, m is the gradient of the required line, which is -1, and y1 x1 is now the coordinate of m, which is where the line passes through. So this is y1 and this is x1 in this case. So we solve. Y minus y1 is 4 divided by x minus x1 equals 2, and m, we've got that to be -1. So all we just need to do here is to cross multiply. Do not forget -1 is the same thing as over 1. So let's multiply all through and cross multiply, then we have our answer. So let's go. Y times 1, that is y, -4 times 1 is -4, equals -1 times x minus x, then -1 times 2, -2, sorry, that's +2. Collect like terms or make everything to the other side of the equation. So this gives me y plus x minus 4 minus 2 equals 0, and that becomes y plus x minus 4 minus 2 is -6 equals 0. So with this, we have found the locus of the point equidistant from 1, 3 and 3, 5.